Hey boss, the viewer, in today's video, as we usually do, we have also some component on the table, and of course some have been common and we've been together with it. There is Arduino, a jumper wire, and in the video of today we'll be talking about this breakthrough board, and it is ADXL335 model, and it is a 3-axis analog accelerometer. Means it can give you the location to the coordinate X, Y, and Z, and as you change the location, the data from means the coordinate from either X, Y, or Z will respond accordingly. So in today's video, we're gonna read the coordinate from X, Y, and Z, and they will be accurate in motion today. Let's get started. So what is ADXL335? The ADXL335, as you see today, you see it is a breakthrough board that is, of course, get name from the chip on it. You can't read it correctly, but on the chip it is written ADXL335B, and it is the main chip on this breakthrough board. And of course, it is a tiny accelerometer that measures acceleration in Y, X, and Z axis. It gives analog output, meaning Arduino can read its value using analog input pins. Means the X, Y, and Z, as you see among the pins as it is labeled there, we have VCC, X, Y, and Z, and that pins X, Y, Z are connected to the analog pin of Arduino, so that you can read accurately and able to read all changes on X, Y, and Z. Luckily, this model doesn't need any library, it is a plug and play. Okay, after knowing the pin description on this model, so let's go ahead and then connect it to the Arduino. The VCC and the ground will go to +5 volts and the GND of Arduino respectively, and then that Z, Y, and X will go to A3, A2, and A1 respectively. So I'm gonna pause the video and then come back with a connected circuit. Okay guys, after that I'm done setting up the circuit connection, and then VCC and the ground are connected via red and brown wire, VCC to 5 volts and then ground to GND of Arduino, and then X out on A1 via orange wire, then Y out via brown wire connected to A2, and then Z via yellow wire is connected to A4. So as I'm done connecting the wire or joining the module with the Arduino, let's jump directly to the computer and see about the code. It means compiling and uploading to the Arduino. Okay guys, as we said previously, we said that module doesn't need any library, and here we are in Arduino, and these are the codes, I mean Arduino IDE, and these are the codes we are going to be using. You see, we started by declaring the variable, means that analog pins on which the sensor will send the data or will communicate with Arduino. Then you have X pin on A1, Y pin to A2 of Arduino, and then Z pin to A3. And if we scroll down there in void setup, because we initialize or we start the serial monitor with the baud rate of 9600, and then there we create a variable in which we restore the readings, means from X, Y, and Z, and then we print those values on serial monitor with the delay for each sequence of 300 milliseconds. So guys, let's have my Arduino connected and then upload the code to Arduino. So I'm going to Arduino, then configure the Arduino board, and then the COM port on which it is connected is already configured. I will choose it just like that and then hit upload. And once it is done uploading, now we are ready to go. Go ahead, then open the serial monitor, and we will start reading the Y and X axis accordingly. Now you see that the model is in one position and the reading on X and Y are still the same. You see that there is no change. We are having 270 on X-axis, then you have 348 on Y-axis, and then Z-axis you have up to 110, which is changing a little how, but that there is no problem. There's a difference of 1. And how this module works is that it detects the position and then send the signal, means the voltage signal in Arduino, and then the Arduino will convert that readings in analog resolution, and we read them in numbers. So you see, when I try to move the sensor, you see that the readings on serial monitor will be changing. Like if I hold it tight in one position, in flat position, just like that, you will see that we are having the y-axis, which is 308, x-axis 339, and then the z-axis, which is 390. So this means that our circuit is responding correctly, and now we can confirm that our model is working well. Guys, this model can be applied in area where we need a precise location or to know if something is tilted or is moving. And if you are a hobbyist who want to play along with this, you can raise your idea from the project that involve like fall detection, gesture controlled robot, vehicle crash detection, earthquake monitoring, and mobile and gaming. As you see, if you can tight it to the hand, and then wherever you move the hand, the corrected data means x, y, and z axis coordinate can trigger any action. Guys, thank you for watching. If you enjoyed the video, please hit like, subscribe, and ring the bell or activate the bell for more coming Arduino tutorials. And if you need one of these components, please go down in the description below. You can find there the information to buy them or the number to contact. Ciao, bye, we love you.